My name is Daniel Abrams, and I am a groundwater flow modeler with the Illinois State Water Survey. This video focuses on the looming water supply shortage that the southwestern suburbs of Chicago will be facing in the coming decades, and possibly within the next decade. There are four main takeaways from this video. First, the deep sandstone aquifers that supply the water to much of the southwestern suburbs are being depleted in an unsustainable manner. Second, we're already feeling the effects, and in certain areas, things could be dire by 2030. Third, the shallow aquifers of the region are also at risk. And finally, this is a regional problem that's been building up for decades, and fixing this will require regional solutions and cooperation. So how do we know the sandstone aquifers are being drained unsustainably? The Illinois State Water Survey has been studying water supply in this region for many decades, and we've collected and continue to collect a large amount of data. These data show that groundwater levels have been falling for a long time. We've used these data to build a groundwater flow model, and this helps us forecast the effects of future demands on groundwater resources in the region. We've joined in a partnership with the Southwest Water Planning Group, which is a collection of communities and industries in the southwestern suburbs. The goal of this collaborative effort is to better understand the water supply issues facing the region. This map shows the main water sources for municipalities in the Chicago region. You can see the Lake Michigan service area, and that's highlighted in light blue. The orange and yellow areas show where groundwater is being used, with orange representing communities using the deep sandstone aquifers. You can see that the deep sandstone aquifers are an important source of water in the southwestern suburbs, with about 30 million gallons per day currently being pumped from them. Our current best estimate is that this is 10 times the amount that the sandstone aquifers can sustainably handle, particularly in Will County. As a result, water levels in this deep aquifer have been declining for well over a century. With Joliet planning to switch off the aquifer in 2030, withdrawals will still be above the sustainable supply. The question then becomes, will the sandstone aquifers for other communities remain at risk? This figure shows what the geology looks like beneath the southwestern suburbs. The sandstone aquifers are shown in the light blue layers, and they're buried deep in this region. The uppermost St. Peter is 600 feet below ground, and the Ironton Gellsville is more than 1,000 feet. The aquifers are covered by impermeable layers, shown in gray. So precipitation falling at the surface here does not reach these aquifers. Water recharging the aquifer actually comes from far away, in north central Illinois and even Wisconsin. That means that it takes a long time to replace any water pumped, on the order of hundreds or even thousands of years. This is the reason that we refer to this aquifer as unsustainable. Now, back in the early 1900s, deep water was under enormous pressure. So when the first wells were drilled, water rose above land surface, and the wells were actually flowing, which you see in the red dashed line. However, water levels have been declining for over the last century due to increasing withdrawals. Currently, water levels have fallen into the layered sandstone aquifers in much of the region. The uppermost St. Peter is actually dry in significant portions of the southwestern suburbs. As a result, sandstone wells have to pump harder to remove the same amount of water, and that means increased maintenance and operating costs. There are also many domestic wells in the region that are at risk of the upper sandstone drying up. Indeed, this has already been observed in some localized areas. Of course, this isn't just a single entity causing this decline. Multiple communities draw from the sandstone and have both local and regional impacts on the aquifer. Industries also rely on the sandstone aquifers, and currently our model has the most at-risk wells occurring at industrial facilities. The model indicates that some of the first wells that will be unable to meet demand in the region will belong to industries, and this could happen within the next decade. So later in this video, I'm going to run through a series of maps This is an example of one of those. Areas like we just discussed are going to be classified in orange and indicate a risk of declining well performance. The table lists some specific reasons for this. In particular, I'd like to discuss the risk of a large new water user. Communities do not have control over the installation of new wells, and the model does not account for all potential new users, like industries. These unaccounted for demands can greatly increase simulated risk depending on the location and the magnitude of pumping. Now let's consider what things could look like 30 years from now, after Joliet has switched off the sandstone aquifer. This cartoon is a simplification of the current trend model scenario developed with feedback from the Southwest Water Planning Group over the last several months. The first thing to note is that, for many communities, water levels have approached the top of the deepest saturated sandstone, the Ironton Gellsville. It is unknown if pumps can physically be lowered to this depth. We already saw that domestic wells in the upper portion of the sandstone are at risk now. By 2050, this risk will be magnified. When water levels approach the top of the deepest sandstone, wells become extremely vulnerable to additional demands from a nearby community or new demands from an industry. This is not an issue that can be resolved by a single community, and this requires regional cooperation. The model simulation indicates some severe complications with the sandstone supply from multiple industries. In every model scenario, the first wells unable to meet demands belong to industries, and this happens within the next decade under the current trend scenario. The conditions I just discussed are categorized as a red zone, indicating severe risk of inoperability for high-capacity production wells. Wells in this risk zone either are approaching or have reached the limit to which pumps can be dropped, at which point wells can become inoperable. All of the wells associated with the orange zone all of the risks associated with the orange zone are magnified in the red risk zone, particularly the risk associated with a large new water user. In addition, water levels falling into the red risk zone will be at unprecedented depths, which can lead to unanticipated complications. Now let's look at how the orange and red risk zones change through time. This map shows current conditions. The orange risk zone, which represents the risk of declining well performance, is already covering much of the southwestern suburbs. It's hard to see, but there is also a small red area where the Sandwich Fault Zone runs under the Des Plaines River. This is the location of some severely at-risk wells that I alluded to earlier. Jumping ahead a decade, we see that many areas experience severe risk of well inoperability. If you're wondering what kind of growth would prompt this, this assumes water demands over the next decade increase similarly to how they did in the early 2000s. This isn't just driven by population. Another factor is the increased reliance on the deep sandstone due to risks to shallow aquifers, which I'll discuss later in this video. This scenario that you're looking at, referred to as current trend, was the result of a months-long discussion with communities and demand experts in the region. In 2029, Joliet remains on the aquifer in this simulation. In 2030, however, Joliet switches off the sandstone, changing sources to Lake Michigan. While a benefit, you may notice this map looks very similar to present day. The recovery of Joliet switching off the aquifer is offset by the water level declines from regional growth over the next decade in this scenario. Moving forward to 2050, you will notice risk areas expanding again due to continued unsustainable withdrawals, with downward trends anticipated after 2050. Without exception, every community in this model scenario had water levels lower than they are today in the southwestern suburbs. It's important to note that you're looking at a single scenario here. Actual growth in demands could be lower in some portions or greater in others. What is clear, however, is that demands are far past the limit of what can be pumped sustainably, and risk does not go away if Joliet switches off the sandstone aquifer. It's also clear that many industries in this region are severely at risk without regional cooperation. I alluded to this briefly earlier, but the shallow aquifers in the suburbs are also at risk. The primary shallow aquifer is the Silurian dolomite. As you see in the image, this aquifer thins out or is absent by the time you approach western Will County. Where available, the dolomite aquifer is often used in conjunction with the sandstone to help meet supply. One major issue is that the shallow aquifers are increasingly showing signs of contamination from road salt, primarily in the form of chloride, which can lead to taste and odor issues in drinking water when exceeding the secondary standard of 250 milligrams per liter. As you see in this plot, concentrations have been increasing for years, and in some communities have approached the secondary standard. Elevated chloride concentrations in drinking water can result in increased treatment costs. Furthermore, there may be complications with meeting NPDES wastewater discharge requirements. The water quality of shallow aquifers is vulnerable to many surficial activities. In addition to chloride, there are a wide variety of newly emerging contaminants, such as pharmaceuticals and pesticides. Finally, shallow aquifer withdrawals are also often under scrutiny for potential ecological impacts. This is particularly true along the Des Plaines River, such as at the Lockport Prairie Nature Preserve. A question that federal Fish and Wildlife is asking is whether future pumping will put unique wetland habitats for endangered species at risk. It is possible that new wells into the dolomite may be prohibited in these areas. The Illinois State Water Survey is working closely with communities in the region to better understand the impact of withdrawals. I would like to close with the idea that shallow aquifers provide some wiggle room when managing the sandstone aquifer. However, as both supplies are increasingly at risk, this balancing act will become much more complicated and cannot continue indefinitely. I'd like to close with a final recap of my 4 main points from this video. First, the deep sandstone aquifers that supply water to much of the southwestern suburbs are being depleted unsustainably. Second, we're already feeling the effects, and in certain areas, things could be dire by 2030. Third, the shallow aquifers of the region are also at risk in terms of water quality and potential ecological impacts. Communities using both the shallow and deep aquifers face a delicate balancing act between these two at-risk resources that cannot be extended indefinitely. And finally, a single community will not be able to resolve this issue. This is a regional problem that's been building up for decades, and fixing this will require regional solutions and cooperation. Please do not hesitate to contact me with any questions, comments, or concerns.